I want to go over an example of finding three variables given three equations. In order to do this, we need to eliminate one at a time, and sometimes it's nice when we can eliminate two at a time, but at least eliminate one variable at a time, then come down to two equations with two variables, something that we know using the process of elimination. So I'm looking at my three equations, and I want to choose a variable to eliminate. So I can choose these, that are the x's, 2, -1, 3. I can look at the y, I'm looking at those coefficients, +2, -2, +3. And then I'm looking at z, 1, -3, 4. And I'm just going to say which one would be the easiest to eliminate. And for today, I'm just going to choose x. What's nice about this is that it does not matter which variable you eliminate. But first, I'm just going to choose x and eliminate x. And I'm just going to put a little mark here to note that that's the one I'm going to eliminate. I eliminate it by pairing up one equation with the other two. So I have to choose one equation and pair it up with the other two. Kind of like we have one guy, two girls, he gets to dance twice. So if I look at this, I think that this equation right here is going to be the one I want to choose to pair up. In other words, if I multiply this -x by 2, it will eliminate that 2x right there. If I multiply -x by 3, it will eliminate that 3x here. So it's going to be the one that would be easiest to eliminate the other two. Let's get started, and I think you'll see. This that has the asterisk, that second equation, I'm going to write it twice. -x plus 2y minus 3z is equal to 16. I'm going to pair it with that first one. 2x minus 2y plus z is equal to -16. And I'm going to go back and I'm going to check and make sure I've written that correctly. -x, 2y, -3z, 16. 2x minus 2y, z equals 16. Pair this second equation up again now with this third one. So we have -x plus 2y minus 3z is equal to 16. Paired up with 3x minus 3y plus 4z equals to -29. Checking again that I've written everything correctly. -x, 2y, -3z, 16. 3x minus 3y plus 4z equals -29. One of the easiest and the most common mistakes is that students do not rewrite the problem correctly. So now what we've done is we've chosen to eliminate the x. Even though when I look right here, I can see that y is easy to eliminate, I have chosen x. Stick with it. So what I'm going to have to do is multiply this top equation by 2. So I have -2x, 2 times 2 is 4y, minus 6z is equal to 32. And the next one, I'm just going to bring that down. 2x minus 2y plus z is equal to -16. When I combine those, the x's will eliminate. That's my whole goal. I've chosen to eliminate the x. So I have 4 minus 2, and that's 2y. -6 and +1 is a -5z. 32 minus 16 is 16. So what I am down, now I'm down to two variables, just y and z. So now I come over to the other side, and I'm going to eliminate the x. In order to eliminate this x right here, I have to multiply this top equation by 3. When I multiply the top equation by 3, we have -3x plus 6y minus 9z is equal to 16 times 3, which is 48. Bring down that second equation, positive 3x minus 3y plus 4z is equal to -29. What happens is that the x's eliminate. That is my whole goal. That's what I've been trying to, I started off doing, eliminating the x's. So we add them up. 6 minus 3 is 3y minus 5z, and 48 minus 29, I'm going to calculate that so I'll make sure it's right, is 19. Now notice what we have. What we have is, we have two equations now, this equation here, with y and z, and we have this equation here with y and z. So we have two equations with two unknowns. We pair them up. So we have 2y, let me get back to a pen. We have 2y minus 5z is equal to 16. I'm going to go pair the other 3y minus 5z is equal to 19. Pairing up those two equations that have the same variables. That's my goal. Every time you pair up, you want to eliminate. So now what I can see that's easiest to eliminate is this 5z right here. So I'm going to multiply, I'm just going to pick this top one up here and multiply it by negative 1. When I multiply it by negative 1, I end up with negative 2y. Let me put this together. Negative 2y plus 5z is equal to negative 16. And then I'm going to bring down 3y minus 5z is equal to 19. When I add these together, I have that y equals 3. Y equals 3. So here's what I've done. I paired up one equation with the other two. So when I paired those up, I decided and determined which variable I wanted to eliminate. And in this case, I eliminated the x's. Once I got that x eliminated, then I came to this direction right here, and I paired up the two equations with two variables. And I get down to one variable, y equals 3. From there, you want to plug in the y equals 3, because our whole goal is to find x, y, and z. You can go back to either one of the yellow highlighted equations. Those are what you want to go back to. I'm just going to plug into this one because I can look at it and bring it right down. So I have 3 times y, which I have found to be 3, minus 5z is equal to 19. So when I saw that, 9 minus 5z is 19, negative 5z, subtracting 9 from both sides is 10, dividing by negative 5, so z is negative 2. So now I have y and I have z. So I've gone over here and I've called this like my sub area, my subways, the place where I do all my substitution. And last but not least, I'm going to go back to one of these equations where I have all 3 variables. Because I have y and z, what I need is x. I personally like to be somewhat consistent, so I always go back to the one I put an asterisk by. It does not matter which one that you use. It does not matter which one, but you need to, go back to something kind of easy. So here, when I have this particular equation, I'm going to just come straight down, and I'm looking at for x. So I have negative x plus 2 times y, and I found y to be 3, minus 3 times z, and I found z to be negative 2, is equal to 16. So I have negative x plus 6 is equal to 16. 2 times 3 is 6, negative 3 times negative 2 is 6. So I have negative x plus 12 is equal to 16. Subtract 12 from both sides, and that's 4. So I want a positive x, of course, so x is negative 4. So my answer is going to be written as an ordered triplet, and it's important that you put that in the right order, x, y, and z. So the answer is going to be negative 4x, 3 for y, and negative 2 for z. Negative 4, 3, negative 2. That would be my answer. Negative 4, 3, negative 2. So here's my answer. Negative 4, 3, negative 2. So I give this test, and one of the things that I am surprised that students do not do, and that is go back in and check. If you want to make sure that this is correct, then you have to substitute every point, negative 4, 3, and negative 2, into every equation. So what you're going to do is you're going to start with that first equation, 2 times negative 4 minus 2 times 3 plus negative 2, and you're going to make sure that that checks out to be negative 16. Then you're going to go to the second equation. Now you have to be careful because this is the opposite of x. So the opposite of negative 4 is going to be positive 4. So I have positive 4 plus 2 times 3 minus 3 times negative 2, substituting in for x, y, and z, and you're going to find that that equals to 16, and that will check out. You can't stop there because sometimes it'll work for 2 of them and not work for the third. You have to check the last one. 3 times negative 4 minus 3 times 3 plus 4 times negative 2 is equal to negative 29. Plugging these back in, even if you have just x and y, plugging those back in is always worth your time to make sure that your answer is going to be correct. So here's my answer here, negative 4, 3, negative 2, and I know it's right because it checked out in all three. This is 3 equations with 3 variables.